Hello and welcome back to Aerospace Testing International's monthly podcast with me, the editor of the magazine, Ben Sampson. So we have had a bit of a break over Christmas and the New Year, but the podcast is back now with a really interesting interview I did last month with John Garvey, who is Chief Engineer of Launch from Virgin Orbit. This interview was conducted shortly after they had successfully reached space for the first time with their LauncherOne rocket, a real milestone for the company. So Virgin Orbit is kind of like the lesser known relative of Virgin Galactic, which tends to get all of the mainstream media attention because of its space tourism angle. Virgin Orbit plans to send small satellites into space using an air-launched rocket that's deployed from under the wing of a Boeing 737. The only other platform to ever do this was Northrop Grumman's Pegasus platform, which hasn't operated for a few years now. But anyway, John's worked in the space industry since the 1980s, working on the Delta rocket program, and also worked on the Clipper reusable rocket, which most people now credit with laying the real engineering groundwork for the reusable rockets that we see companies like Elon Musk's SpaceX and Jeff Bezos's Blue Origin using. John's also started his own companies, including Vector, before working for Virgin Orbit. So as you'll see from this interview, the move from vertical launches to horizontal has been a learning curve, as you'd imagine, not just in terms of the launching, but also in terms of testing. It has a number of implications. But I'll let John do the talking and speak to you on the other side. I hope you enjoy the interview. Okay, John, thanks for taking the time to speak to me today. You are Chief Engineer of Launch now for Virgin Orbit. We've spoken before in one of your previous guises, I know. Can you tell me, when did you join Virgin Orbit, and what are your main responsibilities as Chief Engineer for Launch?
I got on board on June 8th, so it was shortly after the first flight. So a lot of my perspective is having watched that first flight as an outsider, sort of being not in the middle of the and then coming on board. So that's my perspective. Chief engineer for launch, chief engineers have general roles and functions. We have a number of chief engineers, including Kevin Stages, who's overall chief engineer. So there's certain things in terms of technical oversight on launch that I get focus on, but I'm also involved with a lot of any open items. I have to be able to jump in, and if some other folks, if somebody decided to leave the company, I work for Robin, the VP for launch, Robin Ringette. And then I work with Kevin Stages, who's our overall chief engineer, who's worrying about the rocket and other things. But I focus more on issues associated with the launch operations part. So I'm not going to get as involved on the inside of the rocket. That's Kevin's job and his people. Right. But I will deal with, now it's getting more priority, like, boy, how are we going to do launch ops at Cornwall? That's over there. Yeah. And looking at what makes technical sense, particularly as we learn more about our own operations at Mojave, and we want to update and refine. But yeah, having been around a while, I think part of his expectation is I can jump into something temporarily if there's a fire drill and help address those. So that's generally my job activity these days.
So what's the day-to-day like then? What kind of stuff are you dealing with? I mean, is it?
It's bimodal. When we were in the launch campaign, a lot of time would be heading out to Mojave and dealing with stuff on the ground, so-called boots on the ground, which is the fun part, and or being on console, being a launch operator. So watching the GUIs and all that stuff.
Sure.
That's the fun part. That's like being, in the game. And then the rest of the time, like where we're back now, is because of COVID, a lot of it is much more telecom, just like this. The days of going in, and I do miss, and hopefully I look forward to getting back to it, where you go into a room, get the whiteboard, get the markers out, and say, okay, what are we going to do this? And have people get up and work it out real time with 5 people in the room and get that interpersonal dialogue. Right now, we don't have that. So we have to do this mode. So that means a lot more time on the computer, on the phone.
Yeah.
And that's just the nature of the business right now. Right. So I will say COVID has really impacted how we do things. And in a way, the technology for doing remote work, for work from home, if you will, enabled us to do this last launch. I would say what used to traditionally be the back room. So you'd have the mission control center with your core people who are on console that you see in the movies. But then there's the back room with all the rest of your engineers and support people. And you'd call them up if there's a problem. Those folks are now at home. Right. Or they'll be at a facility in Long Beach. And the fact that, like, I'm in my home office, I've got a 43-inch screen. There's been many times where I'll participate in an ops or a test right from here. Right. And the technology is now at that level. And so that's great, but you miss the human dynamic. I can't just look at my fellow person over here and go, does this other person know what they're talking about? And he can give me a thumbs up, thumbs down, and we don't have to do the formal protocol that you otherwise have to now substitute with when you, so it's a trade-off. You know what I'm saying?
Yeah.
But looking forward, when we start going more around the world, if we're going to, I use Cornwall because that's you folks. I'm going to say it's local, for you, it's local compared to me. We don't have to send 20 people there, or we don't have to have a dedicated mini control room like you do now. I can tell our telecom folks, be on standby. You can be doing your regular work, but if we need you to do just like what we sort of did this morning, you can set that up, and there's real efficiencies once you get the basic system in place. And that's one of your questions. How are we looking forward? How do we leverage that so that we can still have that expertise, but I don't have to send 20 people to the UK for 3 months? Can I send a core team of 5 people who turn the wrenches and make sure the stuff is right, but the skill set's here? And then we can do that. We can go to Japan. We can go to Guam. We can go to other places. That's going to be an interesting element of the operations as we move forward.
Sure. Okay. Reaching. Let's get back to where we are right now, though. Reaching space with LauncherOne. Was it last month or December? It was.
It was January 17th. So that seems like last month, but it's only 12 days away. But already so much has happened that January 17th, about 11:30, I'll give or take, depending what you call space. So, not that I was paying attention to it, but.
So what? How did that feel? What did it mean to the company to reach that milestone?
Well, I haven't been through a few of these. It was great. I'll say a major component of it was relief, because there was a lot riding on it, and there was a lot of stress. And every launch I've ever been associated with, there's always 1 or 2 engineers, if not more, who are worried about something. Because this is the type of business where the margins are so small, and we're still early on it, that you can't take it for granted. And this one in particular, after the history of the first launch and the lessons learned, there was still a lot of issues that were like, did we get it right or not? And every time we made it to another milestone, in the launch, as it's flying, you go, oh, good. We made it through max Q. Oh, it made it through stage 7. All right, there wasn't a contact. Hey, look, the second stage started. I think it was more of a relief as opposed to, really super excitement in the positive sense. It's more like, okay, it's working. Once the mission was done, it was like, wow, everything, it really was down the middle once we had the data. But like I said, within a day or two, it's like, okay, that was a major step, but now we've got more stuff to go. And I would say within 2 to 3 days, it's like, okay, we got to empty Hammerhead. We got to get the gear back. We got to have our data reviews. And, by now it's back to, that was good, but we got another flight coming up.
Yeah.
And so but it's much better to be on this side of it, where it's like, but we know we have a rocket that works.
Yeah.
So
you mentioned the first launch there and stuff that you learned from it. What was learned from it really? I thought it was interesting. Okay, I thought it was interesting the way that it was kind of seized upon, certainly by the media over here as a failure. But I know from covering the sector that not everything goes to plan all the time, and sometimes a failure can be as valuable as.
Yeah, it really depends on how you define failure. If you're binary and say, did you finish or not? Did you learn anything? And to the sense it didn't get to orbit, yeah, okay, if that's what your criteria is. On the other hand, if you say we are in a development program and testing, did we mitigate things? Did we learn a lot? Did we reduce risk? Did we prove certain things? Even if it was a short flight relatively, there was a tremendous amount of verification. Just knowing we could fly, drop it from the plane, start it, and get the rocket flying. That alone was tremendous. And sometimes when things like that happen, people overlook it because they go, oh yeah, there was no drama on that part. But the fact that we could do that and make a liquid rocket system get that far on the plane and survive the environments in of itself checked off a lot of boxes. And then there was a lot of data learned in that startup transient and the issues that happened, the failure investigation that led to the successful second flight. We could not have done the second flight. The stuff that we found with the data that, you can do all the ground testing you want, but sometimes you just got to go in that environment and find out what it's like. You can hypothesize and speculate, but once you nail down the parameters, and those insights are what led to the successful launch. I don't, I'll defer to Kevin on this, our chief engineer, but I think it's safe to say that, he can defer on the final thing, but we probably would not have been successful on the second launch if we didn't have the lessons learned and the corrective actions that came out of the first launch. So if you look at it from a total picture, yes, we would have liked to have gone farther, but it was a critical step towards what was the ultimate success on the second flight.
And how many man hours? How would you describe the effort between the first and the second? Was it a kind of manic, we've got to get this done, or is it a kind of planned, anticipated, the step thing?
From everything I've seen and heard about the first phase, there was a lot of first time we're just understanding or figuring out how do you do basic stuff? How do you ship the rocket from Long Beach to Mojave? And a lot of stuff that, again, you take for granted either in your regular life or if you're on a program that's got a history. I used to work, on Delta. So how to transport rockets. Everybody, we got that. But that's not a simple thing. You have to worry about vibration. You have to worry about Department of Transportation, licensing and stuff. And so things that eventually become, I'll say, normal or standard, the first time around, they had to figure that way out. And it can get even more basic. How do you get food to the crew when they're on the airport and they're in the middle of the desert? And that might seem like a trivial thing, but I can tell you, if you have hungry techs, you've got problems that day. And so you work those things out, and then you can focus on the next level of difficulty. So this last campaign, there were a lot of improvements. If you just look, like we went out and we'd say, we're going to do one cryoshock at what we call Necker South 5. And we did it. We found some stuff out, but the number of variances and discrepancies was much smaller. And this time around, they were more manageable. It's like, oh, we just have to part. We know what that part is. It's not like we got to tear the whole system apart to figure out which one component was failing. It's like that regulator, it's not relieving it's not regulating where it's supposed to be. Okay, call up manufacturing and they could bring up the part and replace it that day.
Yeah.
So it's much more focused, the issues.
Yeah.
And that reflects a lot of learning from the first campaign.
Okay. So what with this type of launch, John? I know you've probably done many launches, but this type of air launch, what's the major challenge? What really worries you most?
Well, I'm still learning. I got to admit, every time I look, but flying a horizontal liquid rocket, there are a lot of differences than vertical. Basically, the plumbing is different. That's the simplest thing to say. But, I'm having to learn about snorkels and siphons and things that I've never heard about in the context of a rocket. It might be my brother's boat or something, but, I have to go look up anti-vortex siphon, whatever. Like, how does that relate to what we're doing? But it is interesting the way you have to deal with propellant management when it's horizontal. And that's what this mission demonstrated, was those systems worked the way they were predicted, or there had been enough stuff to say, well, as the ullage bounces around, your sensors are going to give you different readings, that if you're vertical, you're not going to have that problem. So you have to build that into your warnings and your monitoring system. Say, yeah, that's normal. At this point in the flight, we might get these transients on the readings while we go through the transition. So that's what that flight helped refine that. And then there's the element of being on the plane. And again, that's something I'm still learning to appreciate. But that's a stressful environment, being on the bottom of a wing when you're flying transonic, near transonic, next to some really big engines that are putting out these high frequency vibrations.
Yeah.
So having to design to carry it out there, maybe carry it back if you have a return to base on a scrub, and then design to do that 3 or 4 times because you want to have that ability to do it. That changes your acceptance testing. You guys are the testing magazine. Now suddenly, instead of having to test for 20 seconds, you might have to do it for 3 hours because that might be the time you're on wing. And it's those type of things that, again, once you understand the principles, you can work to it. But it's a different thing. Like, the vibe test chamber or the vibe table, you can't do that in an hour. That might take all day to do that type of acceptance test. And so you have to recalibrate that to deal with it. The third thing is with the crew on the plane and having launch capability with the launch engineers actually on the plane. So if there is a loss of communication with the ground, they can operate autonomously. It means we've had to have a much more distributed, mission control architecture. It's not like you have one line, it goes from the rocket straight to mission control. The command and control functions right there, the launch director. Now it's like, well, we have the launch engineers on the plane and the pilot. And we have a distributed system. And in theory, if everyone's connected, that's good. You have more smarts on the problem. But what happens if the comm drops out and the plane folks, the pilot and the launch engineer say, hey, our data is good. It's not a rocket problem. It's a ground station problem. What are the rules for how you proceed in that type of operations? So it's all doable and stuff, but again, it's different. So you have to be careful about extrapolating. That's what I've been learning. You can't just take how you do a normal ground launch rocket or a solid rocket and say, okay, that works 1-to-1. It's like, we have to make some adjustments. And so that's what the last couple of flights have helped validate. Like, those assumptions are good. At the same time, we've identified a few things that we need to now go back and refine. We can constrain some of the margins on the parameters. We don't have to have them this wide. We can tighten them because we're confident that there's not an anomaly associated with those conditions. And that's an ongoing process.
Yeah, I was going to say, I'm guessing that each time you do a launch now, that'll improve and become more efficient and effective, right? Okay.
Yeah.
Go on, sorry. Well, one of my questions was how, what remains to be done before you can sort of get set into that pattern of commercial launches. I mean, the next one's going to be a commercial launch, right?
We had NASA on board, and so in my view, we are a commercial launch company, and we are a research company, and we're going to continue evolving. You look at everyone else; you're always doing that. It's more a ratio of how much, and a lot will depend on how the market evolves. If we're launching 30, 40, 50 times a year, then you're going to have much more of a turn the crank situation. Mm-hmm. And you can only do that if it is turn the crank. You're not changing things. On the other hand, if we're having 10 or 20 in the transition period, those might be more unique. And so there's going to be a balance. I think the difference is now the R&D part can focus more, and it can be more on either process or technology improvements. Whereas before, it's been bet the whole show. We have to prove the basic concept works. As we move on, it's more, can we tighten the margin up? Can we do the startup a little quicker and therefore, or the chill in a little tighter so we have a little more propellant so we get a little more mass for the payload? And that's true of every rocket program. You're never done looking at those parameters. And from a cost and business perspective, that streamlining is really important. If there's an opportunity or a new technology that lets you do something more efficiently, you want to be evaluating it and transitioning it. So it's more, I'd say, going from, does it work, to how do we make it better, or does the customer want something? Mm-hmm. And also some of the innovation will eventually evolve from the rocket more to the ConOps, the concept of operations. And again, I'm going to use Cornwall. Initially, it makes sense probably to do the payload integration in Long Beach, because if the frequency is low enough, you don't want to set up a facility in Cornwall and use it once in a while.
Mhm.
On the other hand, if there's enough market there that says, hey, we're launching 20 times a year, at some point you make a decision, you know what, we're going to invest in that and maybe take advantage of some of the technologies there. And that would be, I would still call that risky because we're making certain assumptions we can do it and then get into the remoteness. Do I have to have the same set of engineers on site there? Or can I have one set in Long Beach who can work remotely with that team, and we only need to have a subset of technicians who can touch the hardware, and I don't have to have a duplicate team and duplicate costs. And that's, to me, that's part of that development process.
That's the key, right? That's what you're trying to unlock here with Virgin Orbit, is that kind of repeatable process, which is going to. I know you're a small satellites guy, and you prefer the cheaper launch. The smaller rockets, the cheaper launch. I mean, that's
less expensive,
right? But what I'm trying to say is that, do you think this company's going to get there with this? I mean, the potential, if it can, is great. Yeah, it's
yeah. Well, that's the challenge, right? We've got to drive costs down. We've got to get repeatability up, because then that, something like the Cosmic Girl, that's a fixed cost. That's always been an issue with air launch. Pegasus had that issue. If you don't fly a lot, you have a lot of sunk costs. Now, that's the same of anybody. You have a launch pad. If you only use it once a year, those fixed costs, the factory. So getting volume is important. At the same time, flexibility is what Virgin can provide, the ability to fly at different places. And that's the debates we're having now, is how much do you bring and be mobile so you can launch at a lot of places, versus how much do you invest and have locally and not transport it? Yeah. At what point does the transportation costs make it worthwhile to invest? And where we're at now, and again, you say my history is I always look and say it's a lot easier to bring a small satellite to my launch site than it is for me to bring my rocket to you and set it up. And that's true if you have to invest a lot of money in a launch pad and certify it. On the other hand, if it's, hey, we're going to fly into Cornwall Airport, Newquay, and we can do that with and come up with not too excessive licensing and everything else, that changes the dynamics. And that's part of what we have to understand. It's like, hey, does University of Surrey and, the ISIS guys in the Netherlands and everyone else, you did an article on nano avionics. Are there enough of those people that it makes sense, for us to fly the plane over, because there's going to be 20 or 30 or 40 people, and at some point there's a transition. That's the fun part of looking at that. And I wouldn't say it's technical, it's business. What's going to drive the model that we invest in? And I'll say SpaceX launched 143 satellites recently, right? The one thing we know is small sats are here.
Right. Yeah.
And what's the balance between doing massive rideshare, which is what SpaceX is proposing, and then the market segment that we and Rocket Lab and others are in, which is, hey, dedicated or smaller numbers where you control your future. That's going to be interesting. I think it's going to be both. It's a question of which is going to be the relationship and the overall magnitude. But I don't think anybody doubts now that small sats are here to stay, and that the future is going to be definitely dependent on that type of implementation.
Okay. All right. Just a couple of more questions, John. Just briefly, I just wanted to ask you about the factors that kind of affect the launch program and the development program. I speak to a lot of engineers. There's time and there's cost. I mean, what do you feel on the program at the moment? What's really influencing the way things happen? I mean, safety obviously is another consideration.
The safety and the integration with the plane and how we do operations with the plane. When do you need to have Cosmic Girl powered on? When do we need to have the flight crew on board? Versus, hey, we can do the testing with just the rocket. And that balance is something that is different. Again, factors in when is the plane available? You have to refurbish it. There's certain FAA. The other thing I'll say that's been really impactful has been COVID. Because we've had to go through all sorts of policy changes and how many people we can have on the pad at a time, who can go out. Somebody tested something. Now we're going to quarantine or isolate till they're good. So we haven't been able to be in an environment that I would say was optimized for doing the R&D and the operations. Now, I've been bringing up, even though we still got a lot to go in the next 2 to 4 months, that's a whole nother subject. But sooner or later, we're going to be in a post-COVID environment. For a lot of reasons, we hopefully are going to be. When do we make that transition, and what does that look like? And that's still kind of, people don't want to socially buy into that sometimes, because that's like, sometime in the future. But that is going to be a big question. And how do we work with customers like that? Because we have to deal with that now. How many people can go in the payload processing facility? What type of testing when the customers show up? NASA opted not to come out to the launch last time because of COVID issues.
Right.
So that has been on top of everything we're doing, and it's hard to extrapolate and say, well, these were the full difficulties, but it was really amplified by the fact that, 2 techs weren't available on Thursday night, so we had to wait till Friday. So did that job really take 2 days, or was it 1 day?
Right.
And so that's been a challenge. And the fact that we could go and do 2 launches in the middle of COVID out in Mojave with what we did, I think really is a testament to the team. And I'll say our HR people and the policies put in place that we were able to go and pull that off. It really made it a lot more of a challenge.
Okay. One last question, John, and it's something I frequently ask people involved in aerospace, and that is, if you were talking to, I don't know, a nephew or someone, and they said, I want to work in aerospace, I mean, what would you say is good about it? And what would you say is bad about about it?
Well, good is obviously it's an exciting time. I'm again, being in the middle, I haven't been around. I've been through a few of these cycles, so I don't necessarily see it from the outside. But when I do talk to those people, or my brothers, I do have the nephews who, I get the email and they think it's the coolest thing. I say, there's a lot of opportunity if you're a young engineer and you're willing to put in the time. But I think that's the key thing is every time you see that Virgin Orbit launch, or you see something fun, or SpaceX does a launch or whatever, there's a tremendous amount of work that went into it. But that's not unique to aerospace. That's true of when you see a sports final. Those athletes have put in a tremendous amount of training so they can just be there on that day. So I tell a lot of those folks is you need to be prepared to put in the hours, and like I'm an ops guy. So I say, you want to work at 12 o'clock on Saturday night, or you want to be there at 6 a.m. on Sunday morning, because that's when you can be of value. And an old guy like me doesn't want to be there. I've done that enough times. So there's opportunities, and you need to figure out how you can fit into that. And also pay attention to the market. Read magazines like yours so you know what's going on. So when you go for an interview, you go, oh, these people just got a big contract. There's certain things about situational awareness that they need to do the research to find out where the niches are, so you can jump on board something that's gonna have legs and be fun.
Great, thanks, John. That's fantastic. It's always really interesting to speak to you. I always enjoy it very much. And thank you.
Okay.
Good stuff. That's some great insights there into running a launch program, such a unique launch program as well that Virgin Orbit are doing there. So thank you, the listener, for listening to the podcast. If you want more of John Garvey or want to revisit it, it will be available to read as a Q&A in the next issue of the print magazine, and also online on our website, aerospace-testinginternational.com. In the meantime, please do subscribe to make sure you don't miss our podcast next month. Thanks a lot. Bye-bye.